Good morning, class. I just pray all of us are okay and so that we can go on from where we started. We were last week. We had probability, and then we looked at the sample space, tossing a coin, flipping a coin, tossing a dice, then picking a card from the different cards that are given. And there we're simply looking at the sample spaces. Today we are going to look at independent events. These are two events whereby the effect on one does not affect the other. Like, for example, if I could look at a coin, in one hand tossing the coin, and then on the other side, in one hand flipping a coin, and then on the other side tossing a dice. Like, the effect, for me to get a 1 on a dice does not affect the fact that I can also get a head on a coin. I can get a head on the coin and at the same time get a 1 on the dice. But the effect this side does not affect the effect at the other side. And for such events, we call them independent events. We can as well have picking a card and then tossing a coin. We can as well have different things. Like last time we looked at the different shapes, color. If you're doing this thing and working with it does not affect this, then we call the two events independent. Like each is independent from the other. And now if we can take a numerical example, we are going to get it from page 198, grade 8 book number 2. And for the grade 7s, I have it written for you here. It says Brian has a coin and a die. What is the probability that he will first flip heads on the coin? Like, what is the probability that when I flip the coin, I'm only going to get heads? They have not talked about the dice, but yet we are dealing with two things. Then part 2, they are talking about tossing a coin, 6, on the, getting a 6 on the die. They have not talked about the coin, but remember it's doing two things at a go. And since I said these are two independent events, you can as well work with one and it does not affect the other. Then C, we have flipping a head and then tossing a 6. And then 4, we have flipping tails and then tossing a 4. So in order for us to do all this, we need to look at the fact that we need to get the sample space. And the sample space is going to be in both of them. Like, we can get the sample space for a coin and then sample space for a die. Like, if we can say this is my coin, for a coin I can either get head or tail. So it is going to be total is 2, and then to get a head is simply a half, and to get a tail is simply a half. Then if I look at a dice alone, I'm going to have, I can either have 1, can either have 2, can either have 3, 4, 5, or 6. So we have 6 as the sample space. Any of them has got an equal chance to appear. So since we are dealing with two things at a go, for me to only get head on the coin, that means I'm not doing anything on the dice because I don't expect to get anything on the dice. The probability here is simply going to look on the coin side and see what is the probability of getting head on the coin, and that would simply be what? Like, the chance of getting head is a half, chance of getting this is a half, simply because we have two likely events to occur, then it is simply a half. Now, to toss a coin, to toss a dice and get 6 on the die, it does not affect the coin. Like, you're working with a dice, for you to only get a 6, it can only appear once. And if it is once, so we are going to have 1 out of the total number of chances, which are how many? Which are 6. We get this from the method for probability P event, where we have number of events over total chances. Chances, like total possibilities. For a coin, there are 2 possibilities. That is why I'm having 2 here. And the head can only appear once. That is why I'm having a half. For a die, to get a 6, there are 6 possibilities. 1, 2, 3, 4, 5, 6. And it is only 1 possibility for you to get a 6. Like, if you want to get a 6, it will only be 1 time. So you get 1 over 6. And then it will be the probability there. If you want to flip a coin and then toss a die and have all of them, like you want head on the coin and then have 6 on the die. You want both of them to appear, like here, like this. You want a 6, and then you want to flip your coin and then get a head. Like, what you get here, of course, does not affect this. and it can only appear once. You have here for a 6, it is 1/6. For a head, it is a half. And since there are two independent events, the total probability of this probability, P head and 6, is simply going to be, you multiply the two. For a coin, it is a half. For a dice, it is a 6. So when you multiply these two, you come up with 1/12 as your probability. And then when you come here down, they are saying you want tails, and then you want a 4 on a dice. For you to get a 4, again, it appears as 1. It is 1/6. And for you to get tails, again, it is a half. So you will have your probability P, tail, and 4. P, tail, and 4, giving you a half for the tail times 1/6 for the 4, which is again a 12. So this is one way of doing this for independent events. The other way could be as listing up all the elements. If you are to list up all the possibilities that we are going to have, head, we can have head 1, we have head 2, we have head 3, we have head 4, we have head 5, and we have head 6. Or tail 1, we have tail 2, have tail 3, we have tail 4, we have tail 5, and tail 6. So when you count all these ones, there are 12 possibilities. And when you come to number 1, which says flip a coin and get heads, to get just head, for it does not consider the 2. There you just look at just the coin and you get half, like what I said. For the toss, to get a 6, you just look at just the die and get 1/6. But when it comes to combining the 2, you say you want head and a 6. You look for where you have head and a 6. It only appears once out of the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that is where we get our 1/12 from. And if you want to get tail and then a 4, you come and look for tail. Tail is there, and a 4. Again, it appears once out of the 12. You come and just write 1/12. Oh, sorry, here I had written 1/12, but it was 12. So basically, that is it. You can either use the multiplication factor because it works for independent events, or you list all the possible outcomes and then just circle out what you've been asked for. That is enough for today, and you can go to your books and check out number, for the grade 8s, you will be doing number 4 and number 3 on page 99. Number 4 and number 3 on page 99. You can as well fill in number 1 on page 198. So you have 1, 3, and 4. 198, number 1, then 3 and 4 on 199. That is for grade 8. Then grade 7, you come and do number 1, and number 4. Number 1 and number 4. Can as well do number 6. Let me see the pages. Number 1, 196. Number 4, 198. Number 6 on 199. They are the 3 numbers that I want you to do. So you can try out them, and if you have any challenges, I'll be online tomorrow. Today, sometime after this lecture, after the video, you can check on me. I'll be there to help you with whatever it is that has become a challenge. Nice time.